Dear students, welcome to 7th HVAC class. We'll be talking about HU dimensioning. You've already read a lot about HVAC system. We are nearing the unit 3, unit 4, now coming to unit 5 when we are talking about HU dimensioning. Some units have common things also like HU dimensioning, they are in earlier chapters also. So, I am telling the HU dimensioning right now. Try to understand the HU dimensioning properly. I am drawing the diagram. This is the HU room plan. HU means air handling unit. I am writing so that there is no confusion. HU means air handling unit. This is the HU room configuration. This is the air handling unit. This air handling unit is placed within the HU room. This is the HU room. The outside is the HU room. This is the plan. The HU looks like this. This is the plan. We are seeing it from the top. As you see from the top, this is the blower section where the blower is placed. This is the chilled water connection. Chilled water is connection here. The chilled water from the chilling machine comes here, passes through it, takes up heat from air and goes out. This is the position through which air comes in. This is the position through which air comes in. Through the pre-filter. This is pre-filter. This is chilled water coil. This is blower. This blower picks up air from cold air from here, and that cold air is passed through duct above these. Cannot be shown in the plan view. It can be seen in the section. From here, the duct comes out, and from duct it goes to the different rooms where it is supplying cold air. Now, this HU has got different dimensions. You can see this dimension is 200. This dimension is 200. This dimension is 900. This dimension is 750. This is the HU dimension, how it is fixed. This HU size depends on the heat load calculated. Heat load means you are calculating in the heat load tonnage. One is tonnage, one is CFM. This is calculated from heat load. Depending on that tonnage and CFM, you make the selection of HU. Higher the tonnage, higher the CFM, bigger is the size of HU in the HU. So you have no control on the size of HU. That cannot be fixed. It depends on the room size, the tonnage, the CFM, and whatever heat load is there for a particular area. But the room size can be fixed from the HU walls. HU walls means these are the HU walls, the outside periphery of the HU. I can fix the room size according to that. Taking that into consideration, we have taken this dimension as 750. I am explaining why each dimension is taken here like this. This is 750 mm. Just remember, all these dimensions are in mm. All these dimensions are in mm. These are all dimensions in mm. The dimensions are all in mm. So, here in 750 mm, why it is taken 750 mm? 750 mm means around 2.5 feet to 3 feet around. Here, there is around 3 feet distance is here. This is being taken because chilled water coil comes here. And along with the chilled water coil, there are different valve arrangements of the HU. You know the valves I have shown in the earlier HU diagrams. Butterfly valve, balancing valve, 3-way mixing valve, pressure gauge, temperature gauge. All are to come in this chilled water coil portion. So this is to be accommodated here in the room, and this is also to be maintained. This chilled water coil is totally to be maintained from here. Coming here, you have to maintain the chilled water coil. Right. This is how the HU room works. This is how the HU room works. There is another thing, important thing which I have missed. Is the door of the HU room. This is door. Door of the HU. Now, this HU room is having 750 mm here to accommodate all the valves, to do its maintenance. A person should be able to move here to open the valve, to clean the valve, and to put it in its place, and all this maintenance work should be done here. So 750 mm is kept here. This dimension from this wall to this HU pre-filter, this is pre-filter. Through this dimension, the air enters inside the HU. This portion through which there is air entering the HU, this portion kept is 900 mm. This is around 3 feet or more than that. This is capped around 3 feet or more than that, so that the air comes here. Air requires a sufficient space to come here. It's a huge volume of air from all the rooms. The return air is coming here from all the rooms. After coming here, it needs some space so that it can enter into the HU constriction. This HU opening, this is the whole HU opening through which the air will enter inside. For that, you need a space of 900 mm. This side is capped 200 mm. This is 200 mm because there is no valve or any important matter here. But this 200 mm is capped so that a person can enter inside and can make the maintenance of the wall. Maintenance of the wall, maintenance of the HU, can do sweeping etc. पोछा लगाने के लिए, sweeping करने के लिए इसको all these relations are given. These all locations are here, and from here the dimension is again 200 mm. This is the back side of the HU. At the back side of the HU, a person should be able to enter, can move, can do washing, sweeping and all the general maintenance work. These two sides do not contain any valves or anything. Valves are contained on this side. Air play, the whole air area where the air play is there. This is this side. So this area is kept 900 mm here, lengthwise, and this is kept 750 mm. Try to understand the connotation of each parameter in the HU room. Then, in the HU room, you can see there is a drain hole. What happens? You have seen in case of when you go through your air conditioner at your home, you have seen during monsoon there is continuous flow of condensate water from the drain of the air conditioning unit in your house. Whether it is a split unit or whether it is a window unit, there is a continuous flow of water you have seen in monsoon through the air conditioner. Similarly, in monsoon, in air conditioner, due to chilled water, the chilling effect, the condensate is formed on the outside of the chilled water coil. This condensate get collected in the HU drain pan. Drain pan is at the bottom. Bottom of the HU there is a drain pan. From drain pan, a pipe is taken to drain hole. In HU room, there should be a drain hole. Through the drain hole, the drain water is going out. These are the must provisions you must keep in the HU room. I am talking about the HU room here. You should definitely understand the HU room very well. You should very minutely and passionately understand the HU room. This is the HU room, and within this HU room, I am taking different parameters into consideration. These are different parameters into consideration in the HU room. Then, other than that, there is a door in the HU room. One important thing to see in the door opens in the outside. The door opens outside. It does not happen inside. Why? Because HU room is generally at negative pressure. HU room is generally at negative pressure. Why HU room is negative pressure? Because it sucks air from the whole system of the building. As return air comes to the HU room, it sucks air. As it sucks with such a high force, a negative pressure is developed. The pressure here is less than the pressure outside. That means delta P is negative here. So if you keep the HU door opening inside, the door will open due to negative pressure. That is why HU room door is always kept opening outside. So that when there is negative pressure and door closes, the door does not come to that side, it just closes the periphery of the HU room. This is very important point in HU room, you have to remember this. This is the HU room door. The door, because of the delta P being negative, delta P means the pressure difference between inside and outside. Here the pressure is less inside, outside pressure is high. Outside pressure is atmospheric pressure, it is lesser pressure because it is sucking air. Because of the suction, negative pressure is created. Because of the negative pressure, if you put the door opening inside, then door will open. Unless you lock the door will open. And you cannot lock the door always because maintenance staff will be coming and going in the door. So to save that, the HU room door always opens outside. This is a direction you are to give to architect very minutely, because architect doesn't know these things. Architect is not aware of these connotations of HU. He doesn't know the door is to open from outside. He may put a door inside, showing it's opening inside, just to save space, but you cannot do that. Door is to be opened outside only. A drain hole, you must ensure there should be a drain hole. The drain hole should have a drain line which will go to the main rainwater pipe of the building. During installation of HU, that is fixed, talking with the plumbing engineers. Plumbing engineers will be making the main rainwater pipe of the building. You connect this drain hole here to the, you don't connect, plumbing engineer connects the drain hole here to the rainwater pipe. And that you as an HVAC engineer is to inform the plumbing engineer before the HU room is made, so that he can make the arrangement for that. That's what is very important in an HU room. I think it is clear up to this point. This is very important aspect, how HU room is designed in a building. In many cases, the architecture, because of his lack of knowledge in HVAC system, does not take at all HU room. This is a very big problem. You are to, whenever you receive an HVAC drawing for making, you first receive an architecture drawing, which the architect gives. In many cases, the architects who are unaware of HVAC system, some architects are, generally all architects are not, good architects know about HVAC system, because big buildings have central HVAC system nowadays. But if some architect is aware of, he may not take HU. I teach in architecture in Manabratna, in architecture department also I teach HVAC. I find in maximum of the architecture drawings there, they don't keep an HU room, because they are not aware of an HU room is required in the system. So this is lack of knowledge of architects. And not only that, not only giving an HU room, he has to give a drain pipe for the provision of drain, and he has to give a door which opens outside. That should be clearly shown in the architecture drawing, and you should ensure that. This is how a HU room is done. I think it is clear, HU room. Now we will move to the next ones. We will talk about false ceiling height. These classes are very important for you, and you can also have these classes because it is saved in the YouTube. You can see all these classes always. When you don't understand, you can see the YouTube and you can understand the classes of yourself. That is very good, because in board drawing, I always omit the drawing, and after that you have to take a photograph to understand that. But here in YouTube you get everything. YouTube in my name, Jaydeep Chakravarti, I have put in the channel. You can get all the drawings there. Now I will tell about false ceiling. Again there is a drawing. This is a total false ceiling drawing I have shown. Now, this is almost, we are coming to the end of the class time. So, you have to draw this diagram, very minutely observe this diagram, and I will be explaining this diagram in the next class. But you should understand all these things I have written. Whatever I have written, you should see all these things very minutely. Here, everything is very important. I will be providing dimensions in the next class. Dimensions of what is the false ceiling height, what is the different distance of different pipes along with the false ceiling, what is the false ceiling thickness, what is the insulation thickness, everything I will put it. And I may ask in the exam to draw a pure false ceiling diagram, coordinated false ceiling drawing. This is draw a coordinated false ceiling drawing showing chilled water pipe, condenser water pipe, supply air duct, return air duct, firefighting pipe, plumbing pipe, all these things. This plumbing pipes is also, it is there. This is plumbing pipe. Plumbing pipe. So this is the total coordinated false ceiling drawing, which I will be explaining in the next class. By that time, you go through the drawing very minutely and see it is understood to you properly. In HVAC, it is very conceptual subject. You have to understand the concept of the drawing, what we are doing at the site, how it is being manufactured and how it is being leveled at site, how it is being coordinated at site. These things are very important in HVAC. Why I will be taking in the next class. Don't worry. Okay. Thanks for attending the class. This is the 7th lecture. And next class will be 8th lecture. Well, I'll be covering all these things. Thank you.